Hello and welcome to this presentation on surds. We're going to recap what you've already learnt at GCSE and then we're going to take that further to look at some A-level content as well. So the first we're going to do is simplify surds, and in this example we've got to simplify root 50, and the way that we do that is to look for the biggest square number that goes into 50, and that is 25. So we can write root 50 as the square root of 25 times 2. We can then split that up into two separate surds, so that becomes the square root of 25 multiplied by the square root of 2, and now you can see why we look for square numbers. So the square root of 25 is 5, and that leads to our final answer of 5 root 2. Just a word of warning here, always then look to make sure that the surd that you are left with doesn't simplify any further, because we would always need to simplify fully. Okay, so now it's time to practice that skill. So just on a piece of paper, if you can have a go at simplifying these surds, please, and then I will go through the answers once you are ready. So in this first one, the square root of 90, the biggest square number that goes into 90 is 9. So this could be written as root 9 times root 10, and then that simplifies to 3 root 10. The biggest square number that goes into 48 is 16, so we could write that as root 16 times root 3, which is then simplified to 4 root 3. The biggest square number that goes into 96 is also 16 again, so that could be written as root 16 times root 6, which then simplifies to 4 root 6. And then finally, rather than multiply the 21 by the 14 and then look for the biggest square number that goes into the result, the more efficient way is to write root 21 as root 3 times root 7. You can similarly write root 14 as root 2 times root 7, and then if you multiply all those component parts together, you end up with a simplified answer of 7 root 6. So it's just a different way of going around it than multiplying the 21 by the 14 first. Okay, good. So on the next 3 slides, we've got a few examples that highlight the skills that you'll need to have for basic surds. I'm quite happy for you to write these down in your notebooks if you wish, but if you'd rather just listen and look and then take notes later if you want to, then that's fine. So in this first one, if you'd like to write down for me what you think the result of adding 3 root 2 and 5 root 2 together is, please. Okay, so this is just like collecting like terms. How many root 2's have we got all together? We've got 8 root 2. In this one, we're multiplying 2 terms together involving surds. So again, if you'd like to write down somewhere what you think the answer to this is, then go ahead. And if we multiply the component parts, 2 7s are 14, root 5 times root 6 is root 30, so we end up with 14 root 30. Word of warning about these, if you end up with an answer, please make sure that the surd you end up with can't be simplified using that skill we've just looked at. In this case, root 30 can't be simplified any further. And in this one, we are multiplying out the brackets. So again, if you'd like to tell me what the result of that would be. And we would end up with 5 lots of root 3 for our first term, and then root 3 times root 3 is 3, giving us 5 root 3 minus 3 as an answer. So another 3 to look at here. So again, you can have a go, and then I will go through them after you have done so. So in this first one, if you simplify root 8 and simplify root 200 and then combine the answers, write down for me what you'd get. One thing to note while you're doing that is you cannot add underneath the square root sign. So this would not be the same as the square root of 208. You can multiply and divide under square roots, but not add and subtract. So root 8 is the same as 2 root 2. Root 200 is the same as 10 root 2, and then if you add those two together, you end up with 12 root 2. In the second example, you're going to multiply out the brackets, so if you'd like to have a go at that, please. And we end up with 4 root 5 as our first term. We end up with root 100 for our second term, but of course root 100 can be simplified to 10. So another case there of always making sure that your surds can't be simplified further. And then in the third example, we're doing a double bracket expansion. So have a go, please. So you might use FOIL method, you might use smiley face, you might use grid method. All of you will have a different way of doing it, but the 4 terms that you end up with when you do expand are these, and they can't be combined. We can't collect any like terms, so that would be our final answer. Okay, good. So these are the final 3, and these are going to lead nicely onto the next topic that we're going to have to look at. All 3 of them are double bracket expansions. So in the first one, don't fall into the trap of thinking you just square the 5 and the root 3. You should be writing 5 plus root 3 multiplied by another 5 plus root 3, and then you can spot that double bracket straight away. You will end up with 4 terms, 25, 5 root 3, another 5 root 3, and then 3. And when you collect all the like terms together, you end up with 28 plus 10 root 3. In the second one, very similar, except this time we are multiplying 2 conjugates together. That is, they are the same terms, but one has a plus connector and one has a minus connector. Now what happens here is that when you multiply these 2 brackets out, the outside term and the inside term are going to cancel each other out. So actually we get left with 25 and we get left with minus 3, and we end up with an answer of 22. So it leads to an integer value. Similarly with number 3, again 2 conjugates, one has a minus connector, one has a plus connector. We're going to get a first term here of 7. The outside term and the inside term are going to cancel each other out, and then we get left with our fourth term, which is minus 2. And again, if you simplify, you end up with 5. So again, an integer value. And the results of those final 2 are very important for the final part of the surds topic. Good. So the final thing left to look at with surds is called rationalizing the denominator. So this is for your notebooks, please. So you can write everything down that you see on this slide. And we will start with this fraction here, 1 over root 3. We don't particularly like that written as 1 over root 3 because the denominator is an irrational number. So the idea in mathematics is we would rationalize that denominator. We would get rid of the surd on the bottom of that fraction. And so we'll do that using fractional arithmetic. So how could we get rid of that root 3 on the bottom of that fraction? Well, we would multiply top and bottom by root 3. By doing that, we're not changing the value of the fraction, but we are changing how it looks. So if we multiply the tops, we get root 3. If we multiply the bottoms, we get root 3 times root 3, and then that leads to our answer of root 3 over 3. So those 2 fractions are exactly the same as each other, but the second one is better because the denominator has been rationalized. And then here is our final example for our notebooks. So again, we have an irrational denominator with the root 3. And so we're going to have to get rid of that irrational denominator. A little bit more tricky this time, but it all comes back to that work on conjugates that I was talking about earlier on. Remember, if we multiply 2 conjugates together, it led to an integer value, which is exactly what we want. So what I'm going to do here to rationalize the denominator is I'm going to multiply the bottom by 2 minus root 3. That's then going to lead to an integer value, and that means that I also have to multiply the top by 2 minus root 3. And if I do that using the skills that I looked at earlier on, I will end up with 4 minus 2 root 3 on the top of the fraction, and I will actually end up with just 1 on the bottom, because the outside term and the inside term are going to cancel nicely, and it will leave me with 4 minus 3. That, of course, can then be written as 4 minus 2 root 3 as my final answer. Okay, great stuff. So that's the end of our surds presentation. We've learnt how to simplify fractions, we've learnt how to perform mathematical operations on surds, and we've also learnt how to rationalise the denominator. So to practice those skills, I'd like you to have a go at these two exercises in the textbook. You can mark them yourself, and then if there's any problems, you can contact your class teacher and they will guide you through any problems that you might have. Okay, thanks very much.